Hey everyone, today I will be discussing this LeetCode problem. So the question name is minimum increments to equalize leaf paths. So let me first explain the question. So the question says you will be given a tree having a number of nodes and each of these nodes will be marked from 0 to n minus 1. So let me first draw a rough tree here. So this is one of the possible tree, and then the question says for each of the node of the tree there will be some cost assigned to it. So you will be given a cost array, and this cost array will represent the cost of each of these nodes. And then you have to find all the possible path from root to leaf node. So for example, for this diagram that we have drawn here, there will be total 4 possible paths from root to leaf node, which is this one, this one, this one, and this one. And then you have to find the cost of each of the path from root to leaf node. So there will be some cost for this path, then for this path, then for this path, and then for this path. And all of this cost will be different initially, and then you have to make changes in the cost of each of the nodes so that at the end cost of all this path become equal. So basically you have to return the minimum number of node whose cost need to be changed so that at the end the path sum of each of these path the cost of each of these path become equal. So now that we have understood the question, let's jump to the solution. So I will be solving this problem with a recursive approach. So initially we have to find the minimum number of changes required to make all the cost of the path equal, considering this 0 as the root node. Now I have written down here the cost of each of the path from root to leaf node. Now we have to make changes and make all this cost of the path equal. So let's see the approach. So in the solution approach, I will be going to the child node of each of the root, and then I will calculate the same thing for each of the subtree. So for the 0th node here, we have 3 child node, 1, 2, and 3. So I will be calculating the same thing for each of these 3 subtree. So now just focus on this leftmost subtree. As you can see, the path sum from 1 to 4 is 8, and the path sum from 4 to 5, 1 to 5 is 9. Let me erase this initial cost. So for this subtree, the cost of this path is 8 and this path is 9. Now you have to make changes and make cost of each of this path equal. And the first node is common to both of these paths. So you can make changes only in the leaf node to make the cost of the path equal. And as you can see, the 5 is the greatest among the cost of each of the leaf node. So I will try to make the cost of other leaf node become equal to 5. So just by changing this 4 to 5, the cost of both of these paths will become equal. And we can say that for this subtree, we need to make only one changes, and then the cost of each of the path will become equal. Now look for this subtree. Here again the second node is common to each of these paths. So just by changing this 3 to 6, the cost of both of these paths will become equal, and we are done with this subtree as well. So for this subtree as well, we require only one changes. And then for this subtree, as you can see, there is only one path, so you don't need to make any change. So we need to make no change for this subtree part. Now see, let me simplify things for you. Let me erase all this rough work. So for this subtree, we were getting the cost of the path equal to 8. For this subtree part, we were getting the cost of the path equal to 12. And for this, we were getting the cost of path equal to 10. Now see, initially we have to find our answer for this 0th node, but we don't know the answer. So let me define this answer equal to 0. Now we will take the sum of the answer for each of the subtree. So for this subtree we required only one changes. For this subtree we required only one changes, and then for the last subtree we required no changes. Now see, this is not our answer yet, because when we solved this subtree part, the cost of the path we were getting was 8, and then for this subtree part we were getting 12, and then for this subtree part we were getting 10. Now see, when we are standing at 0, we can consider the whole subtree as just one single node, and for this single node the cost is 8, and for this subtree, if we consider it as just one single node, its cost is 12, and for this subtree the cost is 10. Now when we make path from 0 to each of these subtree, there will be 3 different paths, this one, and this one. And as you can see, again 0 is common to all these 3 paths, and the cost of these subtrees are different, 8, 12 and 10, and the maximum among them is 12. So we will again try to make the cost of other 2 subtree become equal to 12. So by making 8 equal to 12 and 10 equal to 12, the cost of all the path from root will become equal. So now we have to make 2 changes here, and by doing this, the cost of each of the path from root to leaf node will become equal. So hope now you have understood the solution. Now let me show you how I have coded all this. So this is our recursive function. Our recursive function takes some 4-5 parameters. First of all, the root node for which it has to calculate the answer, then the parent of the root node, so basically the node from which we have arrived to the child node, then the original cost that will be given to you in the question, and then the updated cost. So basically when you are standing at a root node and then going to each of the child node, after calculating the answer for the child node, you were considering the subtree as just one single node. So the path sum for that subtree you will be storing in this updated cost, and then obviously the adjacency list. So initially you don't know the answer for the root node, so you will be initializing answer with 0. Then you will be going to each of the child of the node, and you will be summing the answer of each of the child in the answer. And after you have calculated the minimum changes required for each of the subtree, you will be considering the whole subtree as just one single node, and the cost of that subtree will be the path sum of it. So now you want to get the maximum path sum of all those subtree. So basically you will be going to each of the child node, and from the updated cost you will first figure out the maximum cost among them, and then you will again go to each of the child node, and you will see if the cost of the subtree is equal to the maxi, then you don't need to make any changes. But if the cost of the subtree is not equal to the maxi, then you have to first make it maxi, and here you are again making changes, so you have to consider it in your final answer as well. So you will be doing it here, and then the root in which you are currently standing, you have to update it with the max of the subtree, and then you will be returning the final answer.